Hello class, so we're going to talk about color today. And the first thing you need to know about color is that's a property of light, not of the object itself. So the reason we see a color is because light hits an object and that light reflects back into our eyes. Now, white light, which is what illuminates most of the things we see, contains multiple wavelengths of light. And when white light hits an object, some of those wavelengths are absorbed and some are reflected. The ones that are reflected are the ones we see, and the ones that create the color that we see. So for example, a red shirt, all the wavelengths of light hit the red shirt, and red, the wavelengths that create red, are reflected back, and we see those. If something's white, if an object is white, it's because it reflects all the wavelengths of light. If something's black, it's because it absorbs all the wavelengths of light. Since color is a product of light, changes in lighting will have changes of the color of an object. So grass can appear yellow-green in the morning. It could appear bluish-green towards the nighttime. And it could be a grayish-green on a cloudy day. So an object can really, in effect, change colors. But even though it changes with lighting, we still consider it, we still think of it as the same color. We still think of grass as green, even though it can appear to our eye to be yellow-green, blue-green, gray-green. And this is called the color constancy effect, where we think of it as the same color, even though it optically looks different, depending on the lighting. There's two systems for color. There's the additive system, and this is the system that is used in stage lighting, and the system that's used for LCD monitors. And this isn't the system we're going to be concerned with this class. We're going to be concerned with the subtractive system, and this is when pigments are combined. This is often used by painters, but also in printers as well. So with color, like the way a color looks really depends on the colors around it, and it's kind of similar to value. You know how light or dark something is depends on the colors around it. Well, that goes for colors as well. So I want you to look over here to the right. You'll notice that, or maybe you don't notice it, but I'll let you know that these are the same pink. However, the pink looks different against this yellow background than it does against this red background. It looks darker on this side, I'd say, and it looks more saturated in this instance. The same goes for this this red. It's the same in both cases, but to me it appears brighter when it's placed next to this kind of foresty green. And the same goes for this green. It's the same in each case, but it appears different next to this like fuchsia pink than it does against this kind of flesh tone. And then this kind of baby blue looks different against this kind of seafoam green than it does against this other green. One of the ways of organizing colors is the color wheel. And in this one we have 12 steps. And we have the name of the hues on the outside of the color wheel. And we have yellow, blue, and red. These are the primaries. From the primaries, you can mix those together to create a secondary color. So yellow and blue make a green. Yellow and red make an orange. Now, when you mix a primary and a secondary, you get a tertiary color, such as yellow-orange, or red-orange. And that's the way that this is organized. This really is founded on the primary colors and the colors that these make when they're mixed together. Now the primary colors can't be mixed. You have to start with them. But any of these other colors can be mixed. And you're going to hear me say this time and time again. It's the three properties of color. And the three properties of color are hue, value, and saturation. Okay, so the first property of color is hue, and hue refers to the name of the color as it appears on the outside of the color wheel. And there's many names for colors, lavender, mauve, uh, forest green, racing blue. I mean, just go to any paint supply store and you'll see all types of names for colors. But all these names can be traced to different hues that are on this color wheel. Okay, so in this red, orange, orange, yellow, green, blue, violet, and red violet. So although there's many names for colors, they could all be traced back to these 12 hues. And really the hues that are in between these hues that are shown. Okay, because there exists a hue between yellow, orange, and yellow. Or between yellow and yellow-green. Okay, so in that sense, these hues can be used to make many colors. So how do you control hue? We control hue by first grabbing a paint tube, if that paint tube has the hue you want, or you combine two paint tubes together. So for example, if you wanted a red-violet, you can combine a violet and a red. If you wanted a blue-green, you can combine a blue and a green. So you need to combine two hues together that are on the left and right hand side of the hue you want. Now, the exception is the primaries of red, blue, and yellow. Those can't be mixed. You have to start with them. Okay, the second property of color is value. Value is how light or dark something is. Okay, a lighter color is going to have a lighter value. Okay, the second property of color is value. And value is how light or dark a color is. And every color is going to have a value. Now when you add white to a color, it's called a tint. When you add black to a color, it's called a shade. And of course, if you add white to the color, it's going to make it lighter. If you add black to the color, it's going to make it darker. The third property of color is saturation. And that's how bright or dull a color is. So for example, a stop sign has very high saturation, whereas a faded pink car has a low saturation. Okay, if you look here, this orange is more saturated than this brownish color. This blue is more saturated than this blue. And there's two ways to lower intensity, or also known as saturation, but the same thing. One is to mix the color with gray. The other is to mix it with its complement. If we go back to the color wheel, the complement is the hue that is on the other side, or is on the opposite side of the hue you're talking about. So the complement of red is green. Complement of violet is yellow. Complement of orange is blue. Hello class, so we're going to talk about color schemes. And color schemes are simply, so we're going to talk about color schemes, also known as color harmonies, which are simple color relationships that are often found in nature and often found in art. Now color schemes should be a starting point for your use of colors, if you decide to use them, as opposed to a crutch, okay? You don't want to use color schemes as a formula for using your color choices because it can lead to a dull design. So you just want to use it as a starting point, something to help you to consider the color relationships within a design or an artwork. Okay, and that being said, some artists also prefer a more intuitive approach to choosing colors. And we're going to talk about 5 color schemes. We'll talk about the monochromatic color scheme. We'll talk about the analogous color scheme, the complementary color scheme, split complementary color scheme, and the triadic color scheme. Okay, so the monochromatic color scheme is where only one hue is being used, and there's variations in value. Okay, and that's what you can see in Mark Tansey's work here. Okay, so if you look at this work, what would you say the one hue is? Blue. Okay, blue. How about this one? Red, orange. A monochromatic color scheme can create a strong sense of unity among the work, since everything shares the same hue. Okay, and the next color scheme we're talking about is the split complementary color scheme. This is where you have colors that are opposite on the color wheel. Okay, colors that have hues that are opposite on the color wheel. So, for example, you have red and green. It's a complementary color scheme. Or if you have blue and orange, it's a complementary color scheme. Okay, and complementary color schemes can create, a very jarring and energetic effect on the viewer. Okay, because there's so much contrast, so much color contrast. Okay, and this work by Vincent van Gogh called Night Cafe, reflects a complementary color scheme, okay, of red and green. Now, that being said, there are other colors present. We have yellow. If you look up closer, we have blues. We even have some oranges here. Okay, but primarily, or there's a strong presence of red and green. This work by Monet, strong presence of orange and blue. Okay. An analogous color scheme uses several hues that are next to each other on the color wheel. So, for example, if you have blue-green, green, and yellow-green, this is an analogous color scheme. Analogous color schemes are commonly seen in nature and can sometimes create a soothing effect. So this work by Van Gogh reflects an analogous color scheme. Okay, it has green, it has blue, green, and yellow-green. This work by Pablo Picasso reflects an analogous color scheme. It has blue, blue-green, and green. A split complementary color scheme has a hue, and then the colors that are next to the hue across from it. Okay, so you have green, then you would have, red violet, and red orange. Okay, so if you got green, you'd go across to the complement, red, and you'd go on either side of red. And you would have, like I said, red violet and red orange. And this Firefox logo reflects a split complementary color scheme. So this work by Henri Matisse reflects a split complementary color scheme. We have red, orange, and then we have blue and green. So a triadic color scheme has three hues that are equal distance on the color wheel. So for example, here we got green, orange, and violet. This work by Roy Lichtenstein has a triadic color scheme that uses the primary colors. So yellow, blue, and red. It's actually a very common color combination for pop art. Here's another work whose colors reflect the triadic color scheme.